In this video, we will talk about a new test bot for Apache NuttX real-time operating system. This test bot will test a pull request on real hardware. This is the OS64 SG2000 RISC-V single-board computer, exabyte Pine64. Why are we doing this? Well, before merging a pull request into NuttX, we need to make sure that it runs okay on real hardware. But testing a pull request on real hardware is a real chore that is cumbersome, but yet compulsory. This is why we are finding a better way to streamline the process, to make it a little less painful for the volunteers who are maintaining NuttX. Here we have a sample pull request for NuttX. Now we're going to test this on real hardware. To do that, we will post a comment at the end of the pull request. We will address it to NuttX PR. This is the test bot that will watch out for comments and test our pull request. The command that we'll give to our bot is called test. The bot that will test this pull request is the OS64 RISC-V SBC, and we are testing this on the NSH configuration. This is the most basic configuration for NuttX shell. We do a comment. Right, our comment is there. What happens in the background? We have a test bot here written in Rust that will poll for new comments in NuttX pull request. In a while, our bot will pick up the comment that we have just posted in our pull request. Our bot will identify the location of the code for the pull request. In a while, it will check out the code and build it, then test it. Here we see test bot checking out the code for our pull request. In a while, we'll see our test bot checking out the code for NuttX applications. We'll choose the latest version of NuttX applications. Here's our test bot checking out the code for NuttX applications. Now our test bot will configure NuttX for OS64, and it will start compiling the code from the pull request, starting with the NuttX kernel. Our NuttX kernel is done. Now we compile the NuttX applications. The NuttX kernel and NuttX apps are copied over to our server. This is a TFTP server that will host the image that will be downloaded by our SBC. We power off our OS64 SBC, power it on, and it boots. So we are now looking at a USB serial connection to our real-life SBC. Right now it's running the OS test. This is the standard operating system test app in NuttX. They will exercise everything in NuttX. Earlier we said about turning the SBC on and off. How does that happen? Well, we have an IKEA smart power plug. Our OS64 SBC is connected to the smart power plug. And how we control it is that we use the Home Assistant API. Home Assistant API talks to our IKEA Zigbee hub, which talks to our IKEA smart power plug that's connected to our OS64 SBC. So that's why we're able to automate the whole process of turning on the SBC, booting it, and running a test. The booting of our SBC is handled by TFTP. That is the Trivial File Transfer Protocol. So everything we see here is fully automated. In a while, we'll see that OS test succeeds. Here. And to clean things up, we power off our SBC. Here we see our test bot extracting the important bits of the test log and posting it back to our pull request as a comment, which we see here. This is our original request to test our pull request on real life SBC. And here is the response from our build and test bot. We see that our test bot has compiled this code from a pull request with this commit hash. And here are the actual steps that the test bot executed, configuring it for NuttX, building the kernel, building the apps, copying it to our TFTP server, powering up our all64 SBC, which will boot the NuttX image, NuttX apps, running OS tests to test everything in NuttX. And here's the evidence that everything is okay. It shows that OS test succeeded. And we power off our all64 SBC. And this is how we do automated testing for a pull request on real hardware, the all64 SG2000 RISC-V SBC. To read more details about this solution, check out the article in the video description.